Hello students, welcome to my class. Today we are going to discuss few questions related to P block elements and the pattern is NEET pattern. So friend, let's start the question answer round. Now look at what is the question number 1. Look at the reaction question. What is given here? The reaction of white phosphorus with aqueous NaOH gives you phosphine. That is here is given PH3. Yes sir. Along with another phosphorus containing compound. Clear? The reaction type, the oxidation state of phosphorus is phosphine. As we know, oxidation of phosphorus in phosphine is -3. This is simple one. Now, and the other product respectively, that is we have to find the overall oxidation state of phosphine and the other product. So in this case, what we need to do, friend? So we need to write down the expression. Look at what I am telling, listen carefully. That is white phosphorus P4 treated with aqueous NaOH, put here NaOH and H2O. Now what will give? It gives you PS3, yes sir, then NaH2PO2. Yes sir, now balance it. Here put 3H2O, put here 3, put here PS3, P4, 3P. Now hydrogen in 3 to 6 times, 3 to 6 and 3, 9. Okay, oxygen 3 and 3, 6, 3 to 6. Okay, this is the balance reaction. Now find it out. What is the oxidation in this case? -3, and here is, that is +1. Yes sir. +1 into 2 plus x plus -2 into 2 is equal to 0. Clear to you? That is x minus 4 plus 3 is equal to 0. X minus 1 is equal to 0. X is equal to +1. That is phosphorus one is in -3 and the second one is in +1 oxidation state. Am I right? Now if I look at the question, there is no such options are there. That meant to say this NaH2PO2 further decompose. That is, this is not a stable product. It further decompose NaH2PO2. Further decomposition in presence of heat. And what will happen, sir? It's very simple. In this case, it gives you Na2HPO4 plus PH3. Clear to you what I am telling? NaH2PO2 which gives Na2HPO4 plus PH3. Now what is the oxidation state here? Find it out. Wait for a moment. That is N plus 1, that is 2 into +1 plus hydrogen, that is +1, phosphorus X, oxygen -2 into 4 is equal to 0. Yes sir. That is 2 plus 1 plus X minus 8 is equal to 0. Clear to you? That is X minus 5 is equal to 0. X is equal to +5. That is, here phosphorus is in +5 oxidation state. Yes, and phosphorus here in -3 oxidation state. Now we can say that is when that is the complete reaction, that is PH3 plus Na2HPO4. So this is nothing but a disproportionation reaction and the oxidation state is -3 and +5. Now friend, I am moving here, check it out. That is disproportionation reaction -3 and +5. Disproportionation reaction -3 and +5. Disproportionation reaction are those reactions in which a particular molecule undergo oxidation as well as reduction. Clear friend? Now I am going to rub this part and we'll discuss the next one. Wait for a moment. Now let's move to the next question, question number 2. Extra pure N2 can be obtained by heating, that is NH3 plus Cu. First of all, write down the equation in this case, that is solution. Now, the first equation is NH3, yes sir, plus CuO, okay. It gives you Cu plus N2 plus H2O, clear? This is the first case. Now, next one is NH4NO3, is the first, this one is the second, NH4NO3. Now what will happen, sir? In this case it gives you N2O plus H2O, clear? Now what is the third reaction? Check it out here. NH4 halt twice, NH4 halt twice and Cr2O7. Given here NH4 halt twice Cr2O7. It gives you Cr2O3 N2 plus H2O, clear? Now the third reaction is, tell me friend, that is Ba(N3) halt twice. It gives you Ba plus 3N2, clear to you? Now check it out, all the reaction, which is best one. In this case there are many byproducts, so we need additional method to separate them. In this case there is a formation of N2O take place, not N2. So this one is also not, this method is also not used to the preparation for N2. Now in this case again there are many products, so we need additional method to separate them out. But what we find here, Ba, that is in a solid state and N2 is in a gaseous state. So it's very simple to separate them in a single step. We do not require any other method to separate them. So this is the best method, because one product is in a solid state, the another product is in a gaseous state. So for if we compare the all form method, that is if I take here BaN3 halt twice, then it is the best method to give you the pure N2. So for this, that is D is the correct option. For question number 2, D is the correct option. Now friend, I am going to rub this part and we'll discuss the next one. Wait for a moment. Now let's move to the question number 3. Look at what is given here. The number of SS bond in sulfur trioxide trimer, that is S3O9. That means to say we have to draw the structure of S3O9. So how to draw? That is S here, this one is O, this one is O, okay. Then S here, here is O, then S, then this one, okay. S3O9. Wait for a moment, give me few seconds. This is okay. Now as we know, lone pair O9 1 2 3 O O O O here, that is O and O here. This is the actual structure, clear to you? Count 2, 2, 4, 2, 6 and 3, 9 sulfur. That is the structure of S3O9. Actually, it is treated as double bond, but we know here is lone pair of electron. Better to represent by coordinate bond. So it depends on you how to represent this. In many books, it is like showing like double bond, but double bond is not a correct. This is the representation, but we do not need to check these things, because according to the question we have to find out the SS bond. Here is no SS bond, SO bond are there. So we can say in this case the SS bond in sulfur trioxide trimer is nothing, that is 0. So for third question, that is So again check the structure here. This is clear to you, friend? That is S3O9. So we can say there is no SS bond right here, no SS bond. So for this, what we told, what I told, that is 0 is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next question. Wait for a moment, friend. Now, let's move to the question number 4. The correct order of acidic strength. These all are Cl2O7, SO2, CO2, N2O5, SO3, Na2O, MgO and Al2O3, K2O, Ca. Okay. As we all know, non-metal oxide, listen carefully what I am telling. Non-metal oxides are acidic in nature. That we know, non-metal oxide are acidic in nature. Now the question arises, when we move along the period from left to right, as we all know, non-metallic nature increases. Non-metallic nature increases. Due to this reason, we can say the acidic nature of the oxide also increases. Also increases. What I am telling, the acidic nature of the oxide also increases. Now, if I talk about the first, we have to check the first option. First option is the order Cl2O7 here, then SO2 and then P4O10. Clear? As we know, first come phosphorus, then sulphur. If we move along the period, the non-metallic character increases, so the acidic nature of the oxide also increases. So if I talk about the oxide of chlorine, here is given Cl2O7, yes. If I talk about the oxide of sulphur, that is SO2 is given. If I talk about the oxide of phosphorus, that is P4O10 is given. So in this case, what is the order? It will have more acidic strength. So the order is Cl2O7. Yes, sir. Then there comes SO2 and then there comes P4O10. So check it out. This is the correct order. So this is the correct option. Now check out the second one. Here is given the order. I am going to rub this part, friend. Wait for a moment. If I talk about the second option, what is given here? That is carbon, nitrogen. Clear to you? Then oxygen. Here comes sulphur. As we know, if we move along the period, the acidic nature of the oxide increases. So CO2 has less acidic character than nitrogen oxide and then sulfur oxide. So this is the actual order, but here is wrong. Clear to you? Now third option, let's check. Right here, Na, Mg and Al. As we move along the period, the acidic nature of the oxide increases. So if I talk about the oxide of sodium, here is given Na2O. It will have less acidic character and more basic character, and this is the order, but here is order different. So this is not a correct option. Similar, if I talk about the K2O, CaO and MgO. Now if I write here, wait for a moment, I am rubbing this part. If I write here potassium, magnesium and calcium. Clear? As we know, down the group, basic nature of the oxide increases. Now order is, oxide here is K2O, then For Ca, CaO, then Mg, then MgO. So what about the actual order? First come there MgO, then there comes CaO, and finally we get K2O, because when we move down the group, basic nature of the oxide increases. So MgO has more acidic character in comparison to CaO and K2O, but here the order is different. So B, C and D are not correct option. For this question, A is the correct. Clear, friend? I think now you can easily solve such kind of question. Now let's move to the next section. What I am telling, listen carefully. Now question number 5. There is no SS bond. What to do? We have to find the no SS bond. That is, we need to draw the structure. First, the structure is H2O4 2-. Clear? Now in this case, what is the structure? That is S, that is 2, this one, and this one. This is the structure H2O4 2-. Here in this case there is SS bond. It can also be written like this: S, S, O, then O, then O, then O. Clear? Or like this. That is the H2O4. Now here there is a SS bond. So this is not a correct option. Now moving here, check it out. The next one is, friend, H2O5. S2. So H2O5 2-. Now how to draw the structure of H2O5 2-? Look at here. That is S. This one is S. Check it out. Now here one. This one is O-. Yes, sir. This one is O. Okay. This one is O. And this one is O-. So in this case, what we find here is better to write 2-. That is the structure. Now in this case, what we find here, check it out, sir. It's very simple. Wait for a moment. Clear? Now what we find here, check it out, sir. It's very simple. That is, here is also a SS linkage. So according to the question, what is given? No SS bond. One more thing, in many books it is also given, so not a issue. We have to find it out that this one. So this one is not a correct option. Now friend, I'm going to rub this part and we'll discuss the next one. What is the third option? Check it out. H2O3. Given here H2O3 2-. Clear? Now what to do? That is S, O. Clear to you? That is S minus, that is O minus, that is H2O3. In this case, what we observe again, there is a SS bond. So we can say this one is also not a correct option. Now check out the D option. What is D option here? H2O7 2-. Yes, sir. This one is the D option. Now how to write down? That is S. This one is O. This one is S. Check it out. Yes. One more thing I may mention. Sulphur has valency only 2. But here you can count 2, 2, 4, 2, 6 and 7 not. This is actually the coordinate linkage. But in general practice, we generally assume that there is no such linkage. Only we predict that only there are two type of bond. That is the ionic bond and covalent bond. But this is not a true things. You can use the coordinate bond also. So don't get confused. In this case also, that is like you can use this linkage, because when you find the bond like this, sulfur has a tendency to form double bond, that is 1 and 1 bond. Now here is also a lone pair of electron. Due to this reason the linkage is possible. Clear, friend? So you can easily say, you can easily observe in this case that is the SS bond is not here. So for D is the correct option, H2O7 2 minor. So what we say, that is there is no SS bond, in which case that is H2O7 2 minus. Clear, friend? Now I'm going to rub this part and we'll move towards the next section. Wait for a moment, give me a few seconds. Now let's move to the next question. Which one of the following is the strongest base? As we all know, if we move down the group, that is the basic nature of the hydride what decreases. This is the general theory. What I'm telling, as we move down the group, the basic nature of the hydride decreases and the acidic nature of the hydride increases. And here if I talk about NH3, PS3, ASS3 and SbS3, NH3 is a strong base in comparison to this all. In comparison to this, otherwise NH3 which forms NH4OH, generally we consider it as a weak base. But if we compare the group, if we compare this with group 15 element, then we say NH3OH is NH3 is a strong base in comparison to PS3, ASS3 and SbS3. Clear? So in this case, what is the answer? Sir, the option B. For question number 6, B is the correct option. Which one of the following is the strongest base? Clear? Now friend, I'm going to rub this part. Wait for a moment, give me a few seconds. Now let's move to the next question. Question number 7. A gas cannot be collected over water. N2O2 SO2 PS3. As we know, N2 and O2 can be collected over water. If I talk about SO2 when collected over water, it combines with water and form H2SO3. Clear? That is the acid. So we can say in all the example, all the option, SO2 cannot be collected over water because it combines with water and form H2SO3. So for question number 7, C is the correct option. Clear what I'm telling? For question number 7, C is the correct option. Now friend, I'm going to rub this part and we'll discuss the next question. Wait for a moment. My next question is question number 8. What is given? Aqueous solution of Na2CO3, Na2H2O3, okay, on reaction with Cl2, okay. What will happen here? Look at Na2H2O3 plus Cl2 aqueous here, that is H2O. Clear to you? What it will give? It will give you NaHSO4 and HCl. Remember this reaction? This is the reaction. Na2H2O3 plus Cl2. It gives you NaHSO4 plus HCl. So for this question, what is the correct option? Sir, for this question, B is the correct option. So for question number 8, B is the correct option. Clear friend? Now let's move to the next. Now let's move to the question number 9. Kf combines with HF to form KHF2. What I'm telling? KF combines with HF to form KHF2. The compound contains the species. Okay. What will happen? KF combine with HF. Okay. It gives you, that is K plus and HF2 minus. This is the combination K plus and HF2 minus. Then check out K plus F minus. No, K plus F minus HF. K plus HF2, but this one is not. If I remove this one, that is the C is the correct option. No option are here, so I remove and remove this one, that is H plus, so this is the correct option. Clear to you? So for question number 9, look at K plus HF2 minus C is the correct option. Now take this question, remove this one is not. Okay. Now let's move to the last question. The last question is, look at HBr and Hi reduce sulphuric acid. Okay, that is they act as a reducing agent. Okay, HCl can reduce KMnO4 and HF can reduce H2SO4, KMnO4, K2Cr2O7. As we know, in HF, fluorine is highly electronegative. Yes, sir. Fluorine is highly electronegative. If fluorine is highly electronegative, then it has a very less tendency to lose electron. That is, it will not act as a reducing agent. So it will not reduce H2SO4, KMnO4, K2Cr2O7. So for this question, D is the correct answer. Clear? What I'm telling, for this question, D is the correct answer. Now friend, I'm going to wrap this part and we'll discuss the next segment. That is, now we revise the things again. This is the last question. Now tell me what is the correct option for question number 1. That is, for question number 1, C is the correct option. Disproportionation reaction and -3 and +5. That is C. Now for question number 2, what is the correct option? As I told you, D is the correct option because the product one is in solid state and second one is in gaseous state. So we do not require any additional method to separate them. Now for question number 3, as I told you, as I have drawn the structure, in this case there is number of SS bond is 0. Now for question number 4, what is the correct option? That is Cl2. A is the correct option. Cl2O7, then SO2, then P4O10. Now for question number 5, there is no SS bond. In which case there is no SS bond? In case of H2O7 2-, there is no SS bond. For question number 5, D is the correct option. Now for question number 6, which of the following is the strongest base? Which of the following? As we know, if you move down the group, the basic nature of the hydride decreases in case of group 15 element. So NH3 is the strongest base. Now for question number 7, a gas that cannot be collected over water, that is SO2, because it combines with water and form H2SO3. So for question number 7, C is the correct option. Now let's move to the question number 8. Aqueous solution of Na2H2O3 on reaction with Cl2, it gives, yes sir, it gives B, that is NaHSO4 plus HCl. So for this question, B is the correct option. Question number 9, that is, what will happen? It gives you K plus HF2-. So if I compare, the all options are incorrect, but if I remove this, so we find that okay, we can assume that is K plus HF2- is the correct option. For question number 9, C is the correct option. For question number 10, what will, as we know, F is a highly electronegative atom, so it will not act as a reducing agent. So for question number 10, D is the correct option. So friend, I think now you can easily solve such kind of question, completely theory based question. So practice the question. If you have any doubt, you can easily approach to me. So time is calling friend, time to say bye bye. Thank you so much.